Good afternoon. Today we're going to look at Maclean's Pentagon. I'm going to explain what Maclean's Pentagon is because it's absolutely fundamental to understanding the axioms that we want to use. Let's take a closer look. It's a mathematical pentagon. First I'll say what it is and then we'll construct it. Here we have all 5 possible ways of bracketing a 4-letter word. And the point is that there's an axiom which is shaped like a pentagon for how higher dimensional categories are constructed from arbitrary words with brackets. So why do we care about this? Well, let's go back to counting. As you know, the counting numbers are ordered. That's why the real numbers are ordered, essentially. But in quantum mechanics, the counting numbers are not just numbers, they're dimensions. Let's illustrate this first with triangles in arbitrary dimensions. So a point carries the number 0, an edge carries the number 0 and 1, a triangle carries the number 0, 1, 2. The ordering of ordinary counting numbers is given here by the arrows on the edges. Every such triangular simplex comes from a cube by cutting a slice on the cube. Here we add pink labels for the arrows because that's more information, and we can add a lot of information to our geometry as we go up in dimension. Now we blow up that tetrahedron there in the bottom left to 2 sets of 2 faces so that we can see here an associator. Let me explain. We can look either at the faces or the dual red lines which form the trees that I'm drawing on the right. I can either bracket GH first, or down the bottom now I can bracket FG first, and those are the 2 possible ways of bracketing a word with only 3 letters in it. But now I'm bracketing the edges rather than the little letters I started with. So let's go back to the whole pentagon. What we've done here is we've turned that one arrow on an edge of the pentagon into a 3-dimensional thing, which is the inside of a tetrahedron. So every one of those 5 arrows on the pentagon is really secretly a 3-dimensional structure, and that means that the inside of the pentagon is secretly 4-dimensional, which is nice. That's the dimension of space-time. The reason we care about the squares, or other cubes as well, is because the path to 0 and then to 1, 0, 1 is not the same as 1 and then 0. In other words, the cubes carry non-commutative coordinates, which is completely natural in a space filled up with cubes, and only the slices carry what we think of as commutative coordinates. Pentagonal geometries introduce the golden ratio as a ratio of lengths of a chord to an edge. Let's recap. Each edge in our axiom is an arrow that flips one bracketing on 3 letters to another bracketing on 3 letters, and then no matter how many brackets we have on words with more letters, we can flip between different bracketings using these associator edges. Thank you for listening. See you next time.